This is the Robotic Drum Assist for Multidisciplinary Senior Design 2, Fall 2020. The Robotic Drum Assist is an assistive system meant to help high school students with physical limitations participate in music class as required by New York State. Currently, a hand-over-hand method is used to help students play along to the rhythms set by the teacher, but they lack independence and a true feeling of participation. The goal of this project was to provide an accessible way to physically control a bass drum, snare drum, and hi-hat in real time. Users of the system are able to hit the drums with help from assistive light touch buttons. These buttons can be arranged on a flat platform in any configuration, or removed and held separately to support all abilities and comfort levels.
The main control unit for the Robotic Drum Assist is an Arduino Mega 2560, which handles timing, input processing, and output signal coordination. A tempo slider was provided to allow for automatic playback at varying tempos, ranging from 40 to 200 beats per minute. The tempo was communicated to the user on a 7-segment display built into the final casing. 2 user input modes were designed for this device: real-time control and beat programming mode. In real-time control, hitting a button strikes its corresponding drum instantly. After holding a button for 2 seconds, the device will automatically strike its respective drum by following the beat at the set tempo.
Beat programming mode allows students to select individual half beats and build a repeating rhythm in 4/4 time. A web application was created as the programming interface using a Node MCU microcontroller with a built-in ESP8266 Wi-Fi module. The application can be displayed on any computer or mobile device and can be projected onto interactive smartboards in the classroom. In this mode, the light touch buttons toggle their respective instruments on and off so that students can choose which drums are active.
The main component of the striking mechanism design was the linear door lock actuator, which would push the drumstick into the drumhead at a high speed and force. These motors required high current to work as intended, which was implemented in an H-bridge fashion using 4 relays. Each motor was driven by its own H-bridge circuit. Testing indicated a serious risk of intense heat buildup, which would cause the motors to burn out. A 6 ohm, 50 watt resistor was added to the circuit to handle the stall current and prevent heat buildup. This limited the strength of the motors, but the striking power was still sufficient for the volume and speed required.
Each instrument of the drum set required its own striking mechanism. The snare drum mechanism utilizes a readily available percussion claw along with 2 custom designed and laser cut pieces of wood. A steel strap is created to hold the drumstick to the door lock actuator, and an eye bolt is used to secure the drumstick to the mount and act as a pivot point. The bass drum mechanism utilizes the original bass pedal bass striking mechanism. The pedal was removed and replaced with a door lock actuator. The door lock actuator is mounted utilizing a custom steel bracket along with some minor modification to the structure of the mechanism. The hi-hat mechanism utilizes a full steel construction. All components were custom cut and bent. The door lock actuator directly bolts to the mechanism and utilizes a similar steel strap to hold the drumstick. An eye bolt is also used to secure the drumstick to the mount and to act as a pivot point. The mechanism is bolted to the hi-hat stand with the use of steel split ring pipe hangers.
The box casing that houses the control and power systems was laser cut out of wood and fit together. It features a 2-layer design with the power supply secured on the bottom of the box and the remaining electronics arranged on a shelf above it. The 7-segment display and tempo slider extend out the top of the box. Ventilation holes for the power supply and resistors were added to help manage heat during operation. This casing keeps the electronics safe and secure and completes the Robotic Drum Assist's design.
We want to conclude by thanking everyone who made this project possible and helped us along the way. Thank you to the MSD faculty and staff, our guide Art North, and our customer Molly King.